live. Share on YouTube and go to Viswa.
Go live and answer.
Go live. తర్వాత ఏమొచ్చింది? కొట్టబాక మనం కొట్టు సరిపోతుంది, ఏమనుకో చెక్ చేస్తాం. Hi, good afternoon, Vishwa.
Yeah, good afternoon, sir.
Hi. Yeah, good afternoon. Is my voice audible to you?
Yeah, clear.
Okay. So, good afternoon to all participants. A warm welcome to our faculty development program. So, I am Dr. Balakrishna, head of the Department of Chemistry, Rajiv Gandhi Memorial College, Nandyal. So, I invite all participants. I would like to introduce our speaker. Our speaker is Dr. Pasupuleti Vishweshwar Rao. He completed his PhD from Sri Venkateswara University, Tirupati. Then he had an opportunity to work as a postdoctoral in South Korea. Later, he was appointed as a professor in Malaysia from University Malaysia Sabah. Is it right?
Yeah,
Vishwa?
that's right.
Yeah. So, right now he is occupying a position of head as well as dean for the non-communicable disease sector, and he has almost published 70 international publications, and he has more or less 10 patents almost published, and he is guiding PhD students. Around maybe 10 to 12 students are working under his guidance. So right now I would like to hand over this particular session to Dr. Pasupuleti Vishweshwar Rao. Good luck, Dr. Vishweshwar Rao. Please go ahead.
Yeah, thank you so much, sir, for giving me this opportunity. Even though, despite of all other busy schedules during AMC and also lockdown period. So if you all observe, the duties have been elevated when compared to the normal working days during lockdown. Well, thanks for the nice introduction. So let me straight away go with my talk. So hope you all can see my talk. Is it visible? Whether the slides are visible?
Visible
Not visible, Vishwa? Visible it seems. Yes, visible it seems.
Is it visible?
Yes, audience
Yeah.
or participants are giving you response through chatting.
Okay. So if it is visible, let me start my talk with biomedical applications of nanoparticles. So as we all know that nanotechnology and nanosciences are the booming field or emerging fields. But now we talk about nanotechnology in a different way, since the world and all the research areas are now working on or exploring into the applications of nanotechnology, or some of them might working into the structural synthesis, and some of them are working into applications, and some of
Dr.
them,
Vishwa,
yeah.
Vishwa, just sorry for interruption. Slides
Yes,
are not visible. Maybe you can just check whether You can minimize the cam and just go on to the slides if the slides are visible. Maybe you might have stopped share screening just on the share screen. Share screen. Just check the
Yeah.
shares screen share. Share your screen. Okay, slides are visible. It seems.
Yeah.
Okay, right. Please proceed.
So the slide.
కొంతమంది విజిబుల్ అంటున్నారు కొంతమంది
Yeah, let me check it again.
okay, okay. Share screen.
Then screen seeing everything how to say that.
Vishwa,
Yeah.
at bottom you can notice a share screen. Click on this share screen and open your slides. Open the application window and slides. Okay, please proceed.
Yeah, sorry for the interruption and hope. I'm not sure. Some of the slides are upside down now. Earlier it was okay. Anyways, so let us have a look into the nanotechnology and nanosciences. So, as we all talk about nanotechnology and nanosciences in a very new manner, but actually, the nanotechnology is not new. It exists in the nature since ages.
Yeah.
So, if you observe nanotechnology and its applications really exist in the world since ages, and most of the scientists who worked on fullerenes and other very minute molecules, so they even have got Nobel Prizes. But the only reality is that time they were not aware of this is nano particle or nano size molecules or nanotechnology or nanoscience. So that is why now or nowadays we talk about nanotechnology or nanosciences in a bigger way, which is like usually we say uh, old picture and a new gallery. That is what I say in my own words. So, so the nano is applicable, or now nano is being applied in various fields, including agriculture, medicine, fabrics, engineering, architecture, whatnot. You name whatever the field. So nanotechnology is existing. So if you observe the slide here, and lots of molecules are there, and lots of materials are there with various kinds of nano sizes, which means, and before going further, we all should know that nanoparticles are really invisible with the naked eyes. We cannot see the nanoparticles with our naked eyes. We only can see with some kind of magnifications where you can observe the nanoparticles with the proper sizes and proper structures. In a layman language, if we want to know about the nanotechnology or nanoparticle, say for example, if you take a human hair and then you cut for thousands of times, then you get the nanoparticle. Our human hair is approximately to 800 from 80,000 to 100,000 nanometer in size. Excuse me. So if you see this particular slide, the nanotechnology is not at all new. As I mentioned just now,
Okay. Right.
are the slides visible?
Yes, yes, yes.
Yeah. As I have mentioned just now, nanotechnology is not at all a new subject or is not at all a new field, where it's the combination of sciences, engineering, and technology. Together, we call it as nanotechnology or nanoparticle research. But again, when we talk about nanoparticles, there are various types of nanoparticles available: chemically synthesized, physically synthesized, and biologically synthesized. As a biotechnologist or as a biomedical research scientist, I am more interested in the synthesis of biologically synthesized nanoparticles, which are from microorganisms and plant materials. But usually, I use plant materials to be at the safer side with cost effectiveness. So this is what actually this slide should come later. Anyways, so my research is usually focusing on these particular points. natural product research, diabetes, oxidative stress, antioxidants, cardiovascular diseases, and finally nanoparticle research. Whatever I do, even I do with crude extracts or I do with isolated compounds or nanoparticles, but finally at the end of the day, the applications will be into metabolic disorders, especially diabetes, cardiovascular diseases, hypertension, obesity, wound healing, and so on. So this is the exact example of the definition of nanotechnology. But in a layman language, it's obviously 1 to 100 nanometer in dimension at least, and it involves in developing materials or devices within that size. And here we need to understand the nanoparticles or the nanomaterials scientists or the researchers prepare or synthesize or manufacture or produce will have lots of stability when compared to the normal macromolecular structures. And he is the greatest physicist, Richard Feynman. So he was the one who has actually brought the concepts of nanotechnology. But there was plenty of room at the bottom to explore the possibilities and to explain about what exactly the nanotechnology and the system is all about. And as I just now mentioned, it's like world picture in a new gallery. This is what I made in my own words, saying that usually people say world wine in a new bottle. But here we are talking about the world topic, world, it's an old uh, thing which is existing in the nature, but which is not at all new. Maybe the applications, what we are exploring with the advanced technologies are new, but the technology or the principle of nanoparticles or nanotechnology is still old. And nanotechnology was defined by a Japanese professor, Norio Taniguchi, in 1974. And he has mentioned that nanotechnology mainly consists of processing of separation. Usually, when we do the things, when we synthesize the nanoparticles, it is a process. We separate the things, consolidate, and deformation the materials by one atom or by one molecules. And this is what exactly is mentioned in the previous slide. It's always separation, consolidation, and deformation.
అదిగా సార్ ఎంటీ కాదు సార్ ఇది
Uh,
మీరు లేవు మీరు
excuse
ఉన్నారా
me. Can the others please put off your mic? Yeah, thank you. So, as mentioned just now in the previous slides, the nanotechnology has its applications in various fields. If you observe the above one is food and agriculture, environment and energy, biotechnology, herbal medicine, textiles, medicine or health sciences, aerospace engineering, robotics, information technology, or whatever. As I've mentioned just now, you name whatever the field, nanotechnology exists. And most of the time, people say nanotechnology has lots of prominent applications. And also, sometimes people say the applications or the particle synthesis through nanotechnology is cost effective. But my main area of research is into herbal medicine, which I have highlighted here, and also medicine health sciences, biotechnology, and food and agriculture. These are the different areas what usually I focus on. And this is actually the uh, basics about nanoparticles. These are the fundamental building blocks of nanotechnology, starting point for preparing nanostructured materials and devices, and their synthesis is an important research component. Why we say it's research, nanotechnology research is main component or it's very important component for the current trends of research, because if you take medical sciences or health sciences or any other fields for that matter, the controlled release is one of the main important areas in especially medical fields or health sciences. And another thing is the targeted drug therapies, which is mainly accessible through nanotechnology and nano devices. That is why we always say the synthesis is an important research component, the synthesis of nanoparticles and their existence with stability. Here we have to note down stability is most important when we synthesize the nanoparticles through biological sources. Yeah, in this picture, you can observe there are two types of approaches to synthesize the nanoparticles from various sources. It can be from biological sources and other sources. Number one is bottom-up approach. Another one is top-down approach. Top-down approach means if, say, for example, you have a big rock and then you are, separating it. You are bringing the macromolecule into micromolecular levels. So that is considered as top-down approach. And bottom up, you are building up all the atoms into a molecule, but still the size should be within the nano range with the proper stability and also with good applications. Coming to biosynthesis of nanoparticles, why we call them as biosynthesis and why we call them as biogenic synthesis? Because, as mentioned just now, the nanoparticles can be synthesized chemically, can be synthesized physically, and also can be synthesized biologically, which means using biological molecules or using biological resources to reduce the metals, whatever the metals we use to make them as nanoparticles. So those are the biological macromolecules or biological nanoparticles. So here we learn about biosynthesis of nanoparticles or we discuss about biosynthesis of nanoparticles. So why I choose medicinal plants? As I have mentioned earlier, the importance of any drug, say for example, the medicinal plants have lots of phytochemicals which are safe when compared to the synthetic drugs. Okay, hopefully, it might not be a contradict statement since most of the chemists are here. So it is when compared to the synthetic drugs, natural products might contain less toxic effects or no side effects. So that is why plants play a vital role in human wellness. As we all know, Ayurveda, Siddha, Unani, and all other areas of medicines, complementary and alternative medicines, play a bigger role in ameliorating the complications of diseases such as diabetes, cancers, other metabolic disorders as well. And the main reason to use medicinal plants due to their less or no side effects when consumed. That is number one. And another one is cost effectiveness. Because when we get the materials from the nature, it is very much cost effective. But here we also need to understand if you want to go for an isolation or fractionation, certainly the cost will be increased. It is not as crude, as similar to the crude extracts. So here are some types of nanoparticles which usually we use: silver nanoparticles, copper nanoparticles, gold nanoparticles, and selenium nanoparticles. Not only these, I have just only given four types of nanoparticles just for your understanding. There are zinc oxide nanoparticles, which we also use to, you know, to check the activity of alpha glucosidase inhibitors, which is an in vitro technique for anti-diabetic activities. And we also use silver nanoparticles. We also use gold nanoparticles. So we synthesize using the natural materials. So here another slide has been cut off. I'm not sure why it happened. So before this, there should be another slide, how exactly we prepare the nanoparticles. Anyways, let me take the chance to explain you how exactly the nanoparticle synthesis occurs using biological sources. First of all, we take any plant source materials, which is leaf, root, bark, stem, or whatever, even flowers, which contains various types of polyphenols, flavonoids, terpenoids, or whatever, the metabolites, plant metabolites. Then we make them into powder. Once we make them into powder, then we soak them, or you can directly uh, mix with the metallic ions, and after the reaction it becomes nanoparticles. You can observe the change in color from white to dark color, from light to dark colors. So that is the physical conformation of forming or synthesis of nanoparticles. Then you have to characterize the nanoparticles through various techniques: UV visible spectroscopy or spectrophotometer, then XRD to confirm the structures and morphological structures or morphological sizes. You can confirm with the ACM and FTIR for various functional groups and other techniques as well, even zeta potential or particle size analyzers to confirm the sizes and the activities of the molecules. So you can also check the stability of the nanoparticles for various intervals. It's up to the researcher how long they want to check. Okay, that is about nanoparticles. Once prepare the nanoparticles, what we usually does. So once prepare the nanoparticles, we try to check into the in vivo systems and in vitro systems. First, we check in vitro. That is the usual process. In vitro means in the laboratory conditions, for antimicrobial activity or for anti-diabetic activity or any other in vitro biological activities per se. And in vivo biological activities, usually they are done within the animal. And finally, we collect the tissues or blood samples to measure whatever the parameter we design in the research. But my whole research is always, towards oxidative stress and damage, tissue damages, and then the ameliorative effects of plant extracts and also the nanoparticles. So here, that's why I have mentioned this slide as oxidative stress. It always reflects an imbalance. It is like only imbalance. Whatever we have, if everything is balanced, the health is in a proper way. And also, if everything is balanced, the life is also very happy. If something is up and something is down, which means in a layman language, something is wrong in the system. It may be a cell, it may be a life, it may be an organism, or it may be an organ, whatever it may be, because there is some imbalance, which means some portion of the materials or some portion of the ingredients are more and some portion of the ingredients are less. That is why it is imbalanced. It is not imbalanced. It is not balanced. Once it is balanced, then which means the system is going in a proper way, which means if your system is imbalanced with a high amount of free radicals, which are reactive oxygen species or reactive nitrogen species or other free radicals, then you have toxic substances in the body, which means the cell is undergoing some dangerous effects from dangerous molecules or toxic molecules. If you give or we provide antioxidants, probably with the effect or efficacy of the nanoparticles or antioxidants, the damage may get ameliorated by the nanoparticles we give or by the antioxidants we give. Then it becomes neutralized, which means it balances. It is no more imbalance. So that is the main thing we do. So this is how it looks like, antioxidants and pro-oxidants. So an imbalance favoring pro-oxidants or disfavoring antioxidants. This is how usually when pro-oxidants are more, and certainly the stress will be high in the cells. You can observe different types of pictures here. So these are different types of, see, when you observe the equilibrium on the top of the picture, the right side of the frame, if you observe the antioxidants and the ROS, if they are balanced, it is well balanced. If the ROS is more, then oxidative stress increased. If ROS is furthermore, oxidative stress increases. If you take from down, then it is clearly understood that the amount of antioxidants we provide, the amount of good health we are providing to the cells. And nanoparticles with their biological activities. Okay, this is what we have done almost 7 years back. So we have synthesized the nanoparticles using leaf extract, and then we have checked for antimicrobial activities. So there we have got very good results with the nanoparticles. If you observe, and later on we were hypothesizing this particular three different mechanisms of actions, which is nanoparticle accumulation into microbial cell. What does it do? So this is what exactly we need to understand. If you observe now, most of the journals as well, if we just send nanoparticles or whatever, even plant extracts and antimicrobial activity, none of the journals will take up that. If we study the mechanism of action, then there might be some worth, at least it goes for review. So then we have hypothesized three different types of microbial cell damage and how cell lysis will occur. Interaction of nanoparticles with enzymes, inhibition of signal transduction, thereby lysis may occur. And also second pathway or second hypothesis was interaction of silver nanoparticles in gram-negative bacteria, dephosphorylation of peptides of tyrosine residues, finally lysis, and interaction of silver nanoparticles with the cell walls. So these may produce the free radicals towards the bacterial cell, thereby lysis happens. So another example in the medicine and health sciences, usually the nanotechnology is used in the diagnostics, drug delivery, and tissue engineering. Some of my known laboratories or collaborators, they are working on tissue engineering. I'm yet to reach that particular stage, since the facilities also need to be there. So the institute which we are working, we are not mainly focusing on tissue engineering. So drug delivery can be done, and diagnostics. Even some of the doctors whom we work, they use nanoparticles and nanoparticle doped. Sometimes nanoparticles can be doped with different types of materials, and then they use for various types of diagnosis of different diseases. And this is what uh, I have mentioned in my article in 2014 with current drug metabolism, with various applications of nanotechnology towards diabetes. This article is, I mean, this article only describes about the applications of nanotechnology in diabetes treatment. So how exactly, what are the different aspects and what are the different, you know, molecules or different materials can be used as the treatment for diabetes? Nanotubes, artificial pancreas, nanopumps, microspheres, nanoshells, quantum dots, layer by layer methods, colorants, and smart tattoos. So even for smart tattoos, if you observe the next picture, this is what even I have hypothesized. Just I was just thinking of a particular object and then prepare this. If you observe, now we have smartwatches everywhere, and most of the advanced countries and most of the young generation, they are using smartwatches, to monitor their sleep or to monitor their whatever metabolic rates, whatever. So this is similar to that application. So where an injector sensors are injected using a less invasive technology, and nano tattoos are inserted under the skin, and this can be the readings can be measured by an optical reader. So this is how we have hypothesized, and then halfway we went to the production as well, but somehow it has been uh, stopped halfway due to the budget limitations. So hopefully we will start it again. And nanotechnology approaches for targeted delivery. This is just for the viewers. I've just mentioned, since this is another disease which depicts the neurological disorders and the ameliorations with polymeric nanotherapeutics. So if you observe, they have been surface functionalized and then effectively localized and used for the different types of neurodegenerative disorders. So, which means whatever the disease we name, even our group works on anti-cancer activities of medicinal plants and anti-cancer activities of nanoparticles using medicinal plants. So we do with crude extracts, we do with isolates, and we also do with the nanoparticles. So far, if you have anything, you can just put the questions in the chat box. So if you observe, okay, so far these are the different types of plants we have used for synthesis the nanoparticles. So most of them are Malaysian plants, and some of them are from India as well. And we also work on different types of honeys. Yeah, even this one, these slides, I'm not very sure. After stop sharing the screen, few slides have gone up and down. So this should not be the slide here. Anyways, so these are our few works. Okay. This was an article we studied about Eurochima longifolia, which is also called as Malaysian ginseng. So which we were successful in synthesizing the silver nanoparticles within the range, and we have checked for the stability. The stability was good, and also the anti-cancer activity, because this was the designed biological activity for these particular nanoparticles. So even some of the works been collaborated with one of the organizations from India. And this is just a simple review. Yeah, this is what I was mentioning about current metabolism, where I have clearly described about recent advances in nanotechnology based on diagnosis and treatments of diabetes, where we have clearly mentioned, and also some of the hypothetically mentioned designs are explained in this particular paper. And this one, because why I want to show these things, this is for anti-cancer activity, and this one is general one, diabetes, and this is for agriculture. As you remember my first few slides, I've mentioned that the nanoparticles and their applications are in very wide variety of or wide range of fields, starting from biological sciences, physical sciences, chemical sciences, engineering, architecture, even solar systems or whatever, various types of engineering backgrounds. So the nanotechnology is applied. So this is related to agriculture. We have checked the antifungal and also the growth and biochemical parameters in rice and also maize, along with peanut. So this was a review article which we have clearly depicted the exact mechanisms of anti-cancer agents, how exactly the nanoparticles, act through different pathways, through apoptosis or through anti-inflammatory or other COX pathways. Yeah. So in this picture, you can observe. I'm not sure one of the slides have been lost. So here you can clearly observe plant material with various functional groups, which may be, secondary metabolites, polyphenols, flavonoids, terpenoids, or whatever. They try to reduce the silver ions, which we use silver here, and then finally form the bioreduced nanoparticles. So these particular bioreduced nanoparticle, which you can observe in the center part of the slide, and then you can observe different types of applications: antibacterial activity, antifungal, antioxidant, anti-diabetic, and anti-tumor activity, which is also called as anti-cancer activity. Yeah, this slide which I was talking about, this slide has to be on the top. Anyways, still we have this slide here. So if you observe, these are various types of plant materials I have used, and we combine them with the metal salts. So you can observe you know, the silver nanoparticles. This is just physically we confirm that changing the color may have nanoparticles. But anyways, if you observe here, this is with UV, XRD, FTIR, SEM or TEM, particle size differentiators. So these are all the characterizations we need to do to confirm whether the nanoparticles are in certain shape, certain size, or whether they have stability, they are stable or not. These are the things we should confirm with the characterization once we synthesize the nanoparticles using any kind of metal salts. It is not only silver nitrate, it can be orium chloride or it can be anything else, which I have shown, even zinc oxide nanoparticles. So it depends on the design of the experiment, what the researcher or what the principal investigator wants to continue with or wants to explore with. And finally, we can go for biomedical applications or biological applications, we can say, which can be anti-diabetic, antimicrobial, anti-cancer, or whatever. And we know nanotechnology will change the world. It's time to think about how. Get ready for your nano future. This is from Alan Leo, MIT, a great researcher. And this is my conclusion for the day. Nanotechnology play an important role, not only for human health, but it ameliorates the complications. Say, for example, if you take diabetes, because most of the times you may think I'm using the word diabetes many times because that's my core research. So, diabetes and its complications, whether it can be retinopathy, nephropathy, neuropathy, or whatever. So, it also helps in ameliorating the complications of a particular disease, either diabetes or cardiovascular diseases or hypertension or whatever. But it should be in such a way that the nanoparticles has all the types of functional groups, and also it has the ability to possess that particular biological activity for the treatment. So these are my old photos since 2017-18 photos, and these are all my collaborators across the world, but some of them are missing here. So that's all. So this is apart from different awards, I got this one, which is highly memorable from Reva University, where also an alumni. So you can see all my teachers there. Thank you so much.
Thank you, Dr. Vishnu. It was a fantastic talk. Uh, so for next 5 to 10 minutes, we can have some questions from audience. So
Yeah,
uh,
sure.
for the first question from my side, do you have any advancement from nanotechnology to treat COVID-19?
Yeah, that's a good question, trending question. Recently, we had a discussion with CDCs, Center for Communicable Diseases. So, and we are working on that. And
So
also another group from China we have recently discussed recently, which was on last Friday. We have discussed with two teams from China. They are very much interested to work on herbal medicine and to you know explore the possibilities for the drugs, not only for COVID, other viral diseases as well. So COVID, since it is a trending topic, so probably we may also look into that. But we are not sure how exactly the viral proteins are working because the proper mechanism of action is not yet known. But however, we are trying our best. So even today, despite of my grant application day, I have agreed for this talk.
oh,
So
thank you.
we are working on that now.
So do you think that this level of the nanoparticles aside from plants are more beneficial when compared to nanoparticles that are synthesized from metals? So
Sorry.
how do you compare the functioning of phyto nanoparticles with other metal oxide nanoparticles, Doctor?
Yeah, definitely. As I mentioned in some of my slides, if you observe, the biological sources may have the safe molecules, and they are also having less side effects or no side effects when compared to the chemically synthesized nanoparticles. So that is the main reason now researchers are more focusing on biologically synthesized nanoparticles for the targeted drug therapies or targeted drug delivery systems. But of course, anyways, as we all know, as human beings, we need fast action. So we might need to, you know, stick to the chemically synthesized
Yeah.
molecules. Even as Dr. Balakrishna and I was working on anti-osteoporotic drugs last time way back almost a decade ago. So, which means as a human being, we always depends on the synthetic compounds, which give faster action despite of their undesired side effects. But natural compounds always safe, take long time to cure, but very much safe. That is the main difference between the chemically synthesized and naturally synthesized.
Okay, thank you. Shall we receive some questions from audience? If anybody is interested, they
Sure,
can
sure, please. Sure.
Dr. PV Rao.
Most welcome.
So, Dr. Vishwa, I think you may not hear the voice of audience. They are just
Yeah.
typing questions. They are chatting
Maybe,
the question. Maybe you
yeah,
can answer.
maybe I can pick some of the questions here. One of the participant asked Abida Murtaza, in which form of the nanoparticles are used for antioxidants? Okay, good question. Dr. Abida, it is not which form of nanoparticles. Once we synthesize the nanoparticles, as I mentioned just now, we have to characterize them, whether all the functional groups are there and whether it has been completely capped and it has been properly bioreduced with all the properties. Then we have to check with in vitro studies whether they have any antioxidant properties or not. And finally, if we want to take it orally, we have to dope them with a proper edible materials. So once we dope them with the proper materials, then it can be consumed and it can be utilized as an antioxidant. But we should make sure that the antioxidant properties of the plant extracts and silver nanoparticles are same or even much more, because usually the principle of biogenic synthesis of nanoparticles are to increase the activity. That is what usually we get, and that is what we observe, which means more activity we might get, with different processes.
And Dr. Why most of the nanoparticles are spherical in shape? Could you see the question, Dr. PV Rao?
Yeah, I'm just checking the questions. How
Yeah,
it is tested for blood-brain barrier pass-through. Dr.
yeah.
Rudresh Kumar KJ and Sura Srinivasulu. What is the procedure for the selection of materials and the preparation of nano from biological sources? Okay. What is the procedure for the selections of metal in the preparation of nanoparticles? Okay, I take few questions from here. So Ramya N, good afternoon, sir. What is the procedure for the selection of metals in the preparation of nanoparticles from biological sources? Well, it is not a procedure actually. What is the procedure for selection of metals? So if uh, it completely depends on the researcher, what exactly they want to synthesize. And here, all the researchers and all the participants must keep in mind that we cannot 100% confirm that whenever you're working with silver nitrate, you will definitely or you will certainly form silver nanoparticles. And if it may not form silver nanoparticles, it may form gold nanoparticles, which means it's completely based on the design of experiment from a researcher. So probably you can choose silver nitrate or aurium chloride, which means gold for gold nanoparticles, or even zinc oxide. So it depends on the salts, metallic salts you are using for your study. And another one, what is the procedure for the selection of materials? Okay, Sura Srinivaslu. Dr. Sura Srinivaslu, this is also similar kind of question with Dr. Yan Ramya. So probably, this is based on the uh, experimental design. If we want to, and also another thing is based on the potential biological applications. Because if you observe, some of the biological applications using silver nanoparticles might not be same or similar with the uh, gold nanoparticles, or may not be similar with the zinc oxide nanoparticles, or maybe titanium oxide nanoparticles. So we must first see what is our objective and what exactly we are planning to do with our nanoparticles. Okay. And another question from Adiba. What nanoparticles are especially used to cure diabetes? Well, so this is what we usually do. First, we have to check with the plant extracts whether the plant extract has any anti-diabetic activity or not, like alpha amylose inhibitory activities, or alpha glucosidase inhibitory activities, or beta galactosidase inhibitory activities. You must check, and then you can check whether that particular plant material has the ability to synthesize or bioreduce into the nanoparticles. Yeah. And another question from Bharat Reddy, just now Dr. Balakrishna was reading. Yeah. Why most of the nanoparticles spherical? I share any reason. Okay. Spherical in shape. Is it what you meant? I think, Dr.
Yeah, yeah,
Bhagwan. Yeah, usually whenever I'm not very sure about chemically synthesized nanoparticles, but when we synthesize the biologically, synthesized nanoparticles or biologically reduced and capped nanoparticles, they usually combine with phyto molecules, or they usually combine with triterpenes or phenolic compounds or flavonoids. So once they combine together and they bioreduce and they cap, and once they properly capped or properly bioreduced, so they might get different types of shapes, not necessarily the spherical in shape. Okay, but even though they form in spherical shape, but if you observe the different subforms of the shapes might be different. Okay, hopefully in our biological synthesis or in biogenic synthesis, not exactly most of the silver nanoparticles are in spherical shape. It is not necessary. And hopefully if the spherical shape of the nanoparticles or size of the nanoparticle, in this regard I have to mention, probably they are because of the molecules present in that particular compound, which are really able or capable to reduce the silver ions into the nanoparticles. Yeah. And another one, is there any side effect? Rohit Kumar. Dr. Rohit Kumar, side effects means we, in a biological term or in a scientific terminology, we can say toxic effect. Absolutely. The toxic effects is always, toxic effects are always depends on the molecules present in the plant material. If plant material consists of toxic materials, certainly that might not be your interest to produce silver nanoparticles. Before we go for nanoparticles, we will certainly check for all, whether they have any toxic compounds, whether these particular plant extract can be utilized as antioxidant or can be utilized for biological applications. And okay, Dr. Shilpa BS, Department of Civil Engineering. What are the environmental impacts of these nanoparticles? Good question. Well, when we talk about environmental impacts of these nanoparticles, sometimes people say nanoparticles are toxic. Sometimes people say nanoparticles are not biodegradable. Here we are talking about environmental impacts, but at the same time, if you observe the second the another side of the coin, even the nanoparticles are used for so many environmental aspects. if you observe the food, or if you observe the food technologies or food production, there are lots of nano applications existing. And if you observe in crop improvement or crop developments, so there are varieties of nanoparticles being sprayed, to get large amounts of yields. So it is again all depends on the concentrations of the nanoparticles we are applying into the nature, and the biodegradability of the nanoparticles at certain point of time. So hopefully that gives clear answer to your question. And Wani ions, it is just another synthetic route. How would it change the properties of a nanomaterial? Certainly, Dr. Wani ions, it does not change the properties of the nanomaterials. So it is, as I mentioned, we have different routes, maybe different approaches. I've mentioned we have physical approach, we have chemical approach, and we have biological approach. But it doesn't change the properties of the nanomaterial. It only changes with the source material what we use to synthesize the nanoparticles. So the source material of the nanoparticles, I mean, of the source material for the chemical routes or physical routes or biological routes might differ. So the properties also may change according to the source materials. Yeah, another question from Dr. Vani. I always had this argument that biogenic synthesis is just as synthetic. Yeah.
Dr. Vani is professor from University of Saudi Arabia. He is my colleague
Oh,
from Portugal.
oh, okay. Good to know that.
Yeah,
No wonder many questions from Professor
Vani.
Vani.
Yeah.
That's good. And another one. Okay, Dr. Rudresh Kumar KJ from Nimhans, Bangalore. How do you test nanoparticles cross BBB? Okay, blood-brain barriers. So last time, if I remember my work from South Korea, Dr. Rudresh, we were working with the plant extracts, not exactly the nanoparticles. We used to check with different parameters, including dopamine and other parameters, and we try to check whether they are being ameliorated or whether. But we use the salines, not exactly in the mice or rats. So we might understand, uh, probably we might not able to understand the exact mechanism, but we can understand the possible mechanism of action of nanoparticles through cell cultures. And how is it possible to get rid of side peaks, okay, in IR spectra? Which chemical treatment is suitable for silver nanoparticles? Dr. Swapna Chigari. Yeah, that's again a good question. So usually, peaks of impurities, as here lots of giants from chemistry, are existing. I am completely from biology and biomolecular sciences or biomedical sciences. Still, I work since more than a decade. I work with chemists. Usually, it depends on the preparation of the samples. So, if we take proper care while preparing or synthesizing the molecules, hopefully we try to reduce the impurities. And also, you need to check the blue shifts of the peaks, especially when we are checking the UV peaks. So sometimes they will be shift towards right, and sometimes they will be shift, extremely shift towards the left. Yeah, Dr. Shilpa BS. Just now, again, you have posted a question. What are the environmental impacts of these nanoparticles? I've answered this question just recently. Probably it is audible.
Yes, audible.
Yeah. Is there any other questions?
Maybe Dr. Shilpa has posted again the same question.
Yeah,
What
yeah,
are
that is
the
what.
environmental?
Yeah, if Dr. Shilpa BS is available here, I answer again. What are the environmental impacts of these nanoparticles? Exactly, this is a very good question. There are lots of debates going on toxic effects of nanoparticles, whether chemically synthesized, physically synthesized, or biologically synthesized. However, there are various types of or various kinds of applications which are being used in agriculture, food sector, which are certainly part of environment. Certain types of nanoparticles. Just now, I've shown one of my published articles as well, which we have used in crop development, the growth of the plants or the growth of the crops, which were really good. And here, I again want to stress the concentration of the nanoparticles and the biodegradability of the nanoparticles plays a bigger role in the environmental impacts as long as we don't use harmful concentrations of the nanoparticles that hopefully that may not badly impact the environment. Okay, Deepa, chemistry student. What are the Deepa Aradhya, what are the limitations of nanotechnology in smart delivery of nutrients? Good, that's a really good question. Ms. Deepa, I have published at least two articles in food technology and AI with this particular nanotechnology and other areas. And there we have also mentioned the limitations of nanotechnology in smart delivery of nutrients. Whether your question related to the smart delivery of nutrients into the human system or how. If your question related to smart delivery of nutrients into the human system, certainly the advancements have to be developed or have to be improved more. As of now, you know, certain limitations are there in such a way that the nutrients have to be given to the particular area of the body. So as of now, the technologies or the advancements yet to improve to have this smart delivery of nutrients to the human beings. And yeah, so these are the questions. Hopefully, if no questions or any other questions.
Oh, Dr. Vishwa,
Yeah,
it was a very fantastic presentation and talk, and I think
thank
all
you.
participants have benefited from your lecture. And
Thank you so much.
uh, again, there is one question from for you. If you are
Yeah,
if you are free enough, could you please take that question? Last question.
sure, please.
Khalid, he is also from Saudi Arabia.
Okay, okay. Khalid Al Wakil. Is
Yeah.
there is a need to use reducing agent such as ascorbic acid during biosynthesis of nanoparticle? Yes, of course. Ascorbic acid is nothing but vitamin. Excuse me. So there is a probability. If again, I can say it's all depends on the researcher's purview and your biological application, what exactly the researcher wants to do. And if you observe, ascorbic acid is considered as a natural antioxidant. So before we use this natural antioxidant to be the reducing agent, we must understand why we should use standard natural antioxidant. Even ascorbic acid is used as the standard. and it is also named as natural antioxidant. We should understand why we have to use natural antioxidant as a bioreducing agent. Otherwise, no harm in using it as a reducing agent. Yeah, Deepa Aradhya, nutrients into human system. Yes, yes, Deepa. This is what I would say. As of now, yet to get the advancements properly to use this particular system to deliver the nutrients into the human system. Not only nutrients into the human system, even certain technologies, the proper drug delivery systems to reach to particular organs. Because just now, one Dr. Rudresh, I think, if I'm not mistaken, from Nimhans, asked a very good question related to blood-brain barriers, which means there are certain issues, certain limitations yet to be reached by the scientists to achieve the goals of nanotechnology or achieve the goals of biogenic nanoparticle applications. So certainly, hopefully in the nearing future, we might get the advanced technologies to you know supply the nutrients into the human system properly, and also other systems, not only the nutrient supplies and other drug delivery systems as well, but some of the technologies have already been in use at developed countries, which is very high in cost. That is another drawback of using advanced technologies, not only nanotechnology, but using advanced technologies. They prepare the technologies with lots of cost, and then they try to get the cost by charging the people. So certainly we hope for the cost effectiveness of nanoparticles, which can provide the similar kind of activities into the human system to deliver the nutrients.
Okay. So, Dr. Vishwa, many thanks for your valuable time and for delivering a fantastic lecture and training all young scientists and researchers as well as professors, students, and many thanks for sharing your knowledge and your
Yeah,
experience and explaining about your collaborations, your research articles, and
yeah,
about your ongoing research. And really, it was very great to have a session like with you. And many budding scientists might have benefited from this particular session. And I really appreciate you from myself and from my management chairman, Dr. Shantiramulu Garu, and principal, Dr. T. Jayachandra Prasad sir, and Dean, Dr. Ashok Kumar sir. And on behalf of our chemistry department, I really express my gratitude and thank you to you, Dr. Vishwa. And
yeah,
you can share your contact details for our participants. Maybe if anybody is what you say willing to contact you, they may keep in touch with you for
yeah.
getting some key points from you. So
Thank you so
for
much.
now, yeah,
Yeah, thank you so
if
much,
you would
sir,
like
for
to say,
having me
proceed.
here for this session. So I have shared my email ID for all the participants in the chat box. So you can get my email from there, and then if you have any queries, or if you are willing to collaborate, or if you need any assistance or help from my side, most you're most welcome. So you can take down my email ID, and you can approach me through my email 24/7. And my sincere thanks to my very good friend since more than a decade, Dr. Balakrishna, for having me here with this session. And our collaboration is always, shining. Even you had me
Yeah,
for the reality session last time for the great conference, and even for this virtual uh, faculty development program. So hope we collaborate in many ways, and we grow together and we learn together.
Yeah, sure, sure. Thank you.
Thank you.
So for all participants, tomorrow also we have a session at 2 to 3 p.m. and that session will be held by Dr. Amarnath Reddy from South Korea. So after completing that particular session, I will be posting the feedback form to your registered emails. Then once if you fill your registered feedback form, automatically you will be receiving e-certificates to your email. So this the process of sending feedback form will be after 3 p.m. tomorrow. So please bear and I request to get benefit from tomorrow's session also. So once again, thank you, Dr. Vishwa.
Yeah. Thank you so
So
much. Thank you
yeah,
all, RMC College Management, for
yeah.
having me here. Yeah.
So right now I would like to end the session. So bye to all, and I will be sending the meeting link of tomorrow's session in few minutes to all registered emails. Thank you very much. Bye bye.